You can spend hours matching speakers and wiring a custom enclosure perfectly, only to end up tearing out the wires because the system pushes out an unbearable background hiss or flat, muddy bass. The culprit is almost always the amplifier chip. Makers typically reach for one of 7 iconic amplifier ICs, ranging from the classic LM386 to the modern PAM8403, all the way up to the TPA 3116D2. But the real-world performance gap between them is massive. This chart shows the overall rating comparison across those 7 chips. The scores span a massive gap, from a low 5.0 up to 9.8. Looking at the top bar, the Texas Instruments TPA 3116D2 is the undisputed champion for pure audiophile sound. But dropping the highest-rated chip into any random project often leads to failure. If you don't evaluate your project's physical constraints first, that chip will underperform. In DIY electronics, the definition of best sound is entirely dictated by your available power supply. Most builds fall into one of 3 profiles: a 3 to 5 volt portable or USB setup, a 9 to 12 volt desktop system, or a 12 to 24 volt audiophile rig. Every audio IC requires an engineering trade-off. You are constantly balancing the voltage you can provide against the noise floor and audio fidelity you want to achieve. Trying to run a premium high-voltage chip on a 3-volt battery is like dropping a Ferrari engine into a go-kart. You starve the system and it chokes. Achieving the best possible audio requires finding the specific integrated circuit engineered for the exact voltage you are supplying. Let's start with the most constrained builder profile, the 3 to 5 volt portable setup. In almost every beginner electronics tutorial, you will see legacy chips like the LM386 and the TEA2025B recommended as the default choice. The problem with these older Class AB operational designs is their high self-noise floor. They introduce a constant audible hiss into the signal path, and the bass response remains heavily muffled. Builders choose them to save a few cents and get an easy solder job, but they sacrifice their audio clarity to background static. Modern portable builds require a different approach. Switching to a Class D amplifier topology drastically cuts power consumption by rapidly toggling the output transistors on and off. For low-voltage setups, the filterless PAM8403 Class D chip is the optimal choice. It operates at 85 to 90% power efficiency and drops that ambient noise floor to virtually 0. The required trade-off here is raw output. You gain clean high frequencies and incredible battery life, but the chip strictly limits you to 3 watts per channel. For any battery-powered or USB build, the PAM8403 prioritizes clean efficiency over brute force, rendering those legacy chips obsolete. Moving up to a 9 to 12 volt desktop speaker setup gives builders the headroom to prioritize a specific sonic character. The TDA7297 Class AB chip serves as the primary workhorse for this mid-tier category. It delivers a distinct, warm analog timbre paired with a solid, punchy bass response that many listeners prefer for desktop audio. However, because it uses a Class AB design, it only runs at about 70 to 80% efficiency. You have to install larger, bulky heatsinks to manage the wasted thermal output. Stepping into home theater and true audiophile applications requires entering the premium 12 to 24 volt category. Texas Instruments dominates this tier with their high-fidelity Class D lineup, the TPA 3110, the TPA 31181, and their flagship, the TPA 3116D2. These chips yield an audiophile-grade signal-to-noise ratio. They produce pristine highs and exceptionally tight, deep bass without the background hiss. This technical profile outlines what categorizes them as high-fidelity flagships. Look at the TI series specifications detailed in the bottom right. Hitting these performance metrics, including outputs up to 50 watts per channel, demands a 12 to 24 volt supply, precise matching, and higher cost. With a 12 volt plus supply and the right budget, the TI series provides the absolute highest tier of DIY sound quality. Answering the question of which chip sounds best always begins by identifying your power source. We can map this directly to your constraints. If you are building a portable 3 to 5 volt battery or USB rig, the PAM8403 is the undisputed winner for clean, efficient sound. If you have a standard 12-volt power supply for a budget desktop set, the TDA 7297 is the optimal choice for achieving rich analog warmth. And if you can supply 12 to 24 volts and demand zero hiss with maximum dynamic range, the TPA 3116D2 is the definitive answer, confirming its place at the top of the performance charts. High-end DIY audio relies on selecting an amplifier designed for your specific physical constraints, rather than simply relying on the price tag of the chip.